In this video, I'm going to be talking to you about the two formulas for the definition of derivative. And the first one, this is the one that we were looking at the very end of class last week. So this whole formula here, this is all related to slope. And you see it on a few places in this page. We have the slope of the tangent line, we have the value of the derivative, and these things mean the exact same thing. So when we're talking about the derivative, when we talk about the slope of a tangent line, if we just talk about the slope of a curve, we're talking about the same thing every time. Those phrases are going to be interchangeable for us. So if we take a look at the formula and if we take a look at the first problem that we're going to walk through together, we have this new notation. So this we can read f prime of a, or the derivative of f at a. And what we're looking for is the derivative of f of x at a specific point. And that specific point we're looking for is when x is a. And this can be a little tricky. Like if we look at the first example and it's saying x equals 2, what we're actually going to plug in is we're going to plug 2 in for a in the formula. And this is because this is sort of like our target point. I want to know the value of the derivative when x is 2. Up here, I'm saying I want to find the slope when x is a. So that point, and the point is going to be a comma f of a, that point is our target point. That's the point we're interested in. We want to know the slope at that point. If we want to know the slope when x is 2, we want to know when a is 2. So let's take a look at the formula. If I plug in 2 for a, I'll have f prime of 2 is the limit as x goes to 2 of f of x minus f of 2 all over x minus 2. So there's a few things we need to do in the numerator. We have two items in the numerator. I have f of x and I have f of 2. We're given f of x. We're given that f of x is 2x squared minus 3. We can find f of 2. If we know what f of x is, we can find f of 2 just by plugging it into that equation. So if I plug this in and simplify, I get 5. So f of 2 is really just the y value when x is 2. So let's go ahead and plug that in. So I have the limit as x goes to 2. F of x is 2x squared minus 3, so I'm going to plug that in, 2x squared minus 3. F of 2 is 5, so I'm going to plug that in. This is now starting to look a lot like a problem we would have had a week ago. If I plug in 2 in for x, I am going to get 0 over 0, so I know that I have to do some algebra. Luckily, this is just a nice little factoring problem. So I take out a 2 on top, and then I have a difference of squares. That difference of squares lets me reduce with that denominator. And what's left is something that I can work with pretty nicely. So 2 times x plus 2. If I take the limit as x goes to 2, I plug in 2 for x. And 2 times 2 plus 2 is 8. So 8 is my answer. So that 8 means a few things. The 8 is the value of the derivative at the point. 8 is the slope of the curve at the point. If we look at the next page, these are problems.
With these two exercises, I do want you to try them on your own. What we should do for number 1 first is you should pause the video, attempt number 1 on your own. When you continue the video, I'll give you the answer to the problem, and then if you got the answer, you can skip ahead to problem 2. If you didn't get the answer, I'll go through step by step how to do the problem. So this would be a good spot to pause it now. So the answer to number 1 is 18. So if you got 18 for the first problem, then you can skip ahead on do problem 2 or try problem 2. And then if you didn't get number 1, I'm going to go through step by step how to set this up. So for problem 1, we're using an a value of 3 because our target point is 3. And if I look at that formula from the first page, I would have f prime of 3 is the limit as x goes to 3 of f of x minus f of 3 over x minus 3. So f of x in the formula, f of x is the original function, so I'm going to plug that into the numerator. F of x is 3x squared minus 2. F of 3, I'm just going to find f of 3 on the side over here. It's just what we get when we plug 3 into the equation. I'm going to get 25 for that. I can combine like terms on the numerator, 3x squared minus 27. Now for this, if we plug x equals 3 into our limit expression, we do get 0 over 0. We should get 0 over 0 every single time. If at this point you do not get 0 over 0, then you've made a mistake somewhere else in the problem, so you need to go back and check your work. These problems are going to be, for the most part, they're going to be factoring and reducing problems. So if I factor a 3 out of the numerator, I get a nice little difference of squares. Which I can reduce. So if I look at what's left, 3 times x plus 3, if I plug in 3 for x, 3 times 6, that's the 18. Okay, so at this point what you should do is try number 2 on your own, so you can pause the video. So we'll do the same thing again. You can pause the video and then I'll give the answer and then I'll show the explanation. So for number 2, the answer is 4. So the answer is 4 for number 2. So if you got that, you can go ahead and flip to the next page. If you didn't, then I will work through it with you. So we want x equals 10. So on this one, our a value is going to be 10. So I'm going to have the limit as x goes to 10 of f of x minus f of 10 over x minus 10. F of x is just the original function, 4x plus 7. F of 10, I would do that on the side. That's 47. This one, we do have another factor and reduce type limit. On the top, I have 4x minus 40, and I'm hoping that we can see this. We factor out a 4. We reduce the x minus 10s, and now this is an interesting limit because there's nothing to plug x into. I have the limit as x goes to 10 of just the number 4. If there's nothing to plug x into, that 4 is just the answer.